All right, so on the final review, let's look at this first little group here. We had some questions on 6 through 8. What you want to do is draw a triangle for each of these. So let's just look at 6. So first I'm going to draw a right triangle. So all of these are right triangles. Remember, in your right triangle, C is the hypotenuse, right? The other two sides don't really matter. Let's say this is little a and little b and little c. So this is telling me find the sine of a. So if side a is here, this is angle a over here. Okay, actually, let's put it. Okay, so angle a would be here, b here, c here. Okay, so opposite letters match up. So find the sine of a. Sine of a, geez, is going to be opposite over hypotenuse. Okay, so in this case, your hypotenuse is the C. My opposite side from angle A is little a. Okay, so they've given us some information. Little a is 4. Okay, and then little b is 9. Okay, so to find C, we're going to do Pythagorean theorem. 4 squared plus 9 squared equals C squared. 16 plus 81 equals C squared. 81 plus 16 is 97. So C is rad 97. Okay, so your opposite over hypotenuse, then my opposite was 4. Hypotenuse rad 97. And then we just want to rationalize it. You don't want to leave the radical on the bottom. So multiply by rad 97 over rad 97. So 4 rad 97 over 97. Okay, and for 7 and 8, you're going to do the same thing. Set up the right triangle. Label the sides. Use Pythagorean theorem to find the third side. And then find the trig function that they're asking about. 10, 11, 13. Same thing, draw a triangle. Okay, so let's take a look at number 10. If the cosine is 2 rad 6 over 5. Okay, and says it's a acute angle, it tells me I'm in quadrant 1. So let's set up a triangle. If the cosine is 2 rad 6 over 5, cosine is adjacent, right, over the hypotenuse. So my adjacent side would be 2 rad 6, which would be here. Then your hypotenuse would be 5. If I want to find the sine and the tangent, we have to find that missing third side. So we're going to do Pythagorean theorem again. This time you have 2 rad 6 squared plus b squared equals 5 squared. So 2 rad 6 squared is 6 times 4, or 24, plus b squared equals 25. So b squared is 1, which means this third side here is 1. Okay, so then if I want to find the sine from theta, sine is opposite over hypotenuse, so my sine would be 1/5. Okay, and then the tangent is opposite over adjacent. So from here, my opposite side is the 1, adjacent side is 2 rad 6. So 1 over 2 rad 6, and you want to rationalize that as well. So rad 6 over 12. Okay, same thing for 11, 13. Draw triangles, label the sides. Okay. All right, 17 and 18. We're going to now, again, drawing triangles to find the sine of theta. So for 17, I have a coordinate, 5, 12. So I'm going to put it up here so I have some space. So where is 5, 12? 5 to the right, 1, 2, 3, 4, 5, 12 up. All right, so maybe here. Okay, so once I have my coordinate, you're going to draw your triangle in. So your right triangle, you always have theta at the origin. Okay, this length is 5. This length is 12. Pythagorean theorem tells us our hypotenuse, 5 squared plus 12 squared equals c squared, right, would have to be 13. So if here's my angle, and I want to find the sine of this angle, it's going to be opposite side, which is the 12, over the hypotenuse, which is 13. So our sine is 12/13. All right, 18. Same thing, except now we're going to be in a different quadrant, right? Because now our point is -2, -3. So let's draw our triangle. Here's our theta. This is -2, -3. We're going to do Pythagorean theorem to figure out the third side. So 2 squared plus 3 squared 4 plus 9 is 13. So this is rad 13. Okay, and we want to find the secant. Okay, so what's a secant? Well, secant's reciprocal of cosine. If cosine is adjacent over hypotenuse, that means your secant would have to be hypotenuse over adjacent. So in this case, my hypotenuse is rad 13. Adjacent side is negative 2. So it's going to be negative rad 13 over 2. All right. 25, 26. Reference angle. So how do we find a reference angle? We need to figure out where is 660 on the unit circle, and then you find the closest angle to it. Okay, so 60, or the closest, but the reference angle with the x-axis. So 660, so you want to draw this. Okay, so on the unit circle, where's 660? Well, here's 0, here's 360. So one time around is 360. To go 660, I need to go 300 more, which is going to put you here. Okay, so if this is 660, how much more do I have to get to my closest x-axis? Okay, well, 2 full revolutions would be 720, right? 360 times 2. We went 660, so minus 720 minus 660. I have 60 degrees. Okay, so my reference angle is 60 degrees. I could put a triangle in here. It's 30, 60, 90. We're looking for cosecant. Okay, well, remember your 30, 60, 90. This side is going to be 1/2. This is going to be rad 3 over 2. So your coordinate here is positive 1/2, negative rad 3 over 2. You're looking for a cosecant. Cosecant is reciprocal of sine. Your sine is your y value. Okay, so my sine is negative rad 3 over 2. So your cosecant, if we flip that, negative 2 over rad 3. And then you want to rationalize. So rad 3 over rad 3. Negative 2 rad 3 over 3 would be for 25. All right, 26. Let's take a look at 26. Again, reference angle. Figure out where this is. Okay, so this is a little different because you're in radians. But remember, you have 0, pi, 2 pi if you go all the way around. Well, how much pi do I have? 7/6. Okay, so that's 1 and 1/6. So I go 1 pi, 1/6 more. So if this is 7/6, this is 1 pi. The difference between the two is pi over 6, which is your reference angle. Okay, and then we're going to draw our triangle in there. And at pi over 6, you got to figure out what's the angle there. Okay, so again, you have a 30 degrees, 60 degrees. Okay, so your long side's rad 3 over 2. Short side is 1/2. In this case, negative 1/2 because you're going down. So the coordinate there at that spot on the unit circle is negative rad 3 over 2, negative 1/2. We're trying to find the tangent. How do you find the tangent? Tangent is sine over cosine or y over x. So our tangent would be y coordinate divided by the x coordinate. And then we're going to flip this, right? So negative 1/2 times 2 over rad 3, both negative. Negatives cancel, 2's cancel. So just 1 over rad 3, and then you want to rationalize it. So rad 3 over rad 3, which gives you rad 3 over 3. All right, 27 through 29. Again, we're just drawing triangles here. Okay, so this tells you what quadrant to go in. It says my sine is 1/6, and then my secant is negative. Okay, so that's telling you which quadrant to go into. So I'm going to first set up my triangle. Okay, remember all students take calc. That represents which ones are positive and which quadrants. Okay, so if my secant, okay, so sine is positive, which tells me I could be in 1 or 2. Okay, but my secant is negative, which means we are not going to be in quadrant 1 because they're all positive. So this is telling me I'm in quadrant 2. So let's draw our triangle in quadrant 2. Okay, sine is 1/6. Sine is opposite over hypotenuse. So 1/6. Okay, and then we use Pythagorean theorem to find your third side. So a squared plus 1 squared equals 6 squared. A squared plus 1 equals 36. A squared is 35, so A is rad 35. So this is rad 35. And we are looking for cosine and tangent. Okay, so cosine would be adjacent over hypotenuse. So rad 35 over 6. Okay, and it's going to be negative because this is negative because we're going left. So negative rad 35 over 6. And then tangent, opposite over adjacent. So your opposite is 1. Adjacent is negative rad 35. So you have tan equals 1 over negative rad 35. And then you're going to rationalize that. So rad 35 over 35. And it's going to be negative. Okay, so for 28 and 29, same thing. Draw the triangles. Figure out what quadrant to go in. Set up your right triangles. Okay, graph. Let's take a look at the graph. So this is -3 cosine x minus pi over 2. So you need to know what the base graphs look like, and then we'll see what's going on here. This -3, the negative is an x-axis reflection. The 3 means I have an amplitude of 3. And then this is a shift to the right, pi over 2. Okay, so the normal graph of cosine starts up at the top. So it'd start up at 1, goes down to the right. Okay, so this is what our cosine graph would look like. The basic graph. Okay, we're not drawing the base graph, we're drawing -3 cosine, all this stuff. So what's going to change? Instead of starting up at 1, we would start up at 3 because we have an amplitude of 3, but we also have a reflection. So we're actually going to start at -3. Okay, so we're going to go up. But now, instead of starting on the y-axis, we also have a shift of pi over 2. So we're actually going to start here. Okay, and then up to the right, then all the way up to +3, down to -3, up. Okay, so it's going to look like that. And let me get rid of that red one because we don't want that at all. Okay, so you got to remember what that base graph looks like. If you don't remember, just look it up. Okay. All right, 33. Cotangent graph. The only thing that's changing is it has a reflection. Okay, that negative x-axis reflection. So it's going to change what direction your curves look like. Okay, your asymptotes aren't going to change at all, so they are still going to be on the y at pi and pi over 2. Our curves are just going to be going the other way. Whoa. Okay, so they're going to look like this. All right, and 34, secant. Secant is reciprocal of cosine. So the first thing you want to do is graph cosine graph. So we want to graph y equals 2 cosine 1/3 x. Okay, so I have an amplitude of 2. My period is always 2 pi divided by whatever is in front of the x. So 2 pi divided by 1/3, in this case, is going to be 6 pi. So let's start by graphing that graph. Okay, amplitude 2, 6 pi is my period. Okay, so 6 pi, half of 6 is 3. So I'm going to split this up into fourths, just so it, like, it's not really in fourths, is it? Okay, cosine graph starts at the top, goes down. So in this case, I'm going to start up at 2, go down to the right, down to -2, back to the center, up to +2. Okay, so this is my cosine graph. Okay, but that's not the graph I want. I want the graph of the secant graph. But to get the secant graph, we need the cosine graph. So then you would go ahead and draw in your asymptotes. Okay, and then your secant curves are going to go at every maximum and minimum. So I have one here, and then one here. And that's enough for that picture. Okay, so you just need to know what the basic graphs look like, and then you go from there. All right, 35 through 38, these are our inverse functions. So what this is saying, inverse cosine negative rad 3/2. So inverse means two things. One is telling you which quadrants to look at. Okay, remember this inverse functions had restrictions on them. And then once you narrow it down to what quadrant you want to be in, you just figure out, well, what angle in that quadrant has the sine or cosine of this. Okay, and 35 in the case of negative rad 3/2. Well, inverse cosine is limited to quadrants 1 or 2. Okay, if it's negative, that tells me I'm in quadrant 2. So what you're doing is looking in quadrant 2, and you can just look at your unit circle. Where do you have an x coordinate of negative rad 3/2 in the second coordinate, or in the second quadrant? Okay, so in the second quadrant, we have one at 5π/6, right? 5π/6, your x coordinate is negative rad 3/2, then up 1/2. Okay, so that's your answer there, is just 5π/6. Okay, so inverse, this is asking you which angle makes that. Okay, so for 36, tangent, inverse tangent is in quadrants 1 or 4. Okay, I have a positive, so it tells me I'm in quadrant 1. So we're looking in quadrant 1 for a tangent of rad 3/3. So to get a tangent of rad 3/3, you need to divide the y-coordinate by the x-coordinate to get rad 3/3, and that happens at π/6. Okay, at π/6, we had a coordinate of rad 3/2 up 1/2. So if I take 1/2 divided by rad 3/2, it's 1/2 times 2 over rad 3, just 1 over rad 3. When you rationalize it, it's rad 3/3. Okay, so that was at π/6. So that's what you're looking for there, is the angle. All right, so for 37, it says inverse. So first start with this. Okay, what's the cosine of 7π/6? Well, the cosine of 7π/6, by just looking at your unit circle, is negative rad 3/2. Okay, but that's down in quadrant 3. Okay, so this is this insight. So now what I'm saying is, well, what's the inverse cosine of negative rad 3/2? Okay, it's not going to be 7π/6 because that doesn't fit into our restrictions. Remember, your restrictions are you're in quadrants 1 or 2. Okay, so if it's negative, I have to be in quadrant 2. So you're looking in quadrant 2 for a cosine of negative rad 3/2, and we found that already in question 35. That happens at 5π/6. All right, 38. We need to draw a triangle because there's nowhere on my unit circle that's going to have a cosine of 1/3. Okay, so we're going to start with this inside piece. It's saying what angle has a cosine of 1/3? Well, remember, cosine is in quadrant 1 or 2. Inverse cosine is positive, so I know I need to be in quadrant 1. Let's draw a triangle. It's saying what is this angle here if the cosine is 1/3? Well, cosine is adjacent over hypotenuse. So if my cosine is 1/3, what's the angle measurement? Well, I don't even need to know the angle measurement because really what you're just trying to find is what's the tangent of that angle. Okay, so to find the tangent of that angle, we can just do Pythagorean theorem, find that third side, do opposite over adjacent. So Pythagorean theorem, 1 squared plus b squared equals 3 squared. 1 plus b squared equals 9. B squared is 8. So b is rad 8, or 2 rad 2. Okay, so now that I know it's 2 rad 2, you're looking for tangent. Well, tangent is opposite over adjacent. So 2 rad 2 over 1 is just 2 rad 2. Okay, so if the numbers are from the unit circle, use the unit circle. If your numbers like 38 are not from the unit circle, you're going to have to draw a triangle. All right. 39 through 41, because we're just simplifying using the identities. Okay, so like for instance on 39, you're going to want to combine the fractions. They're fractions. To combine fractions, you need common denominators. So I'm going to get them both to have the same denominator, which in this case would be 1 plus sign and 1 minus sign. So this first fraction, you'd multiply by 1 minus sign, numerator and denominator. Second fraction, we multiply by 1 plus sign. Okay, so what are we left with? You have sine times 1 minus sine times 1 plus sine all over 1 minus sine, 1 plus sine. Okay, well the denominator, when you FOIL it out, becomes 1 minus sine squared. Okay, which ultimately becomes cosine squared. Okay, now numerator, let's distribute and see what we have. So you have sine minus sine squared. Minus sine minus sine squared. Okay, so the sine minus sine is nothing. Numerator, I have minus 2 sine squared over cosine squared. Okay, and remember sine squared over cosine squared is tangent squared. So this is the same as negative 2 tangent squared, or C. Okay, 40, let's just distribute. See what happens. Okay, so distribute the numerator, which is cosecant. All right, so let's first change everything. Here, let's take it down here. Okay, so cosecant is 1 over sine, right? And then you have sine squared plus cosine squared. Tangent is sine over cosine. Okay, which already one of my cosines is gone. Okay, and so now let's distribute. This is just the numerator. So 1 over sine times sine squared is just sine, plus these sines, when you do 1 over sine times sine cosine, the sines cancel out and it's just cosine. And then your denominator is also sine plus cosine. So if they are the same, we get 1, which is C. Okay, and then let's take a look at that last one. Let's see. You can factor. Let's factor out a cosine, leaving you with 1 minus sine squared. Okay, and 1 minus sine squared is the same as cosine squared. So cosine times cosine squared is cosine to the third, which is again C.